Hi students, today we are going to do experiment number 1 for Robo 124 logic gates. We are going to analyze the function of the logic gates. Observe this, the IC should be placed on the breadboard like this. You are using two different sections and therefore the pins of the IC are separated. Now pin number 14 is VCC and pin number 7 is ground. So a black wire is shown for 7 and red wire for 14. The first thing is to check the function of IC 7404, which is a NOT gate. The NOT gate is going to invert the signal. If you give a high at the input, it's going to produce a low at the output. The input connection is like the previous experiment. We are going to connect plus 5 volts to one end of the switch, the switches, and the other end of the switches are going to be grounded. 7404 is a one input gate, so we are going to use only one switch. Now when the switch is open, this 5 volts is going to be available here, which is logic 1. The gate is going to invert it to a 0. That 0 is going to forward bias the LED because plus 5 volts here to the anode of the LED and cathode of the LED gets a 0, which is forward biasing. The LED should glow. So the LED should glow when the switch is open. When the switch is closed, the 5 volt supply is going to supply current in this line and nothing is going to be available, like a 0 is going to be available for the input of the NOT gate. That 0 is inverted to a 1 here. That 1 is similar to having 5 volts. So 5 volts here and 5 volts here is not going to properly bias the LED. Therefore the LED is going to be in the off state. I have hooked up the connection circuit here. Switches 2 and 3 are getting the resistors and the other end of the resistor is connected to power supply, and on this side I have connected switches 2 and 3 together and I have taken it to the negative of the power supply. Now I am using switch 2 alone for this circuit. So from switch 2 I am connecting to pin number 1 of the IC and pin number 2 of the IC goes to negative of the LED. Positive of the LED gets 330 ohms and the other end is connected to power supply. On the IC there is a groove and I have to start counting the pin numbers from this side. 1, 2, 3, 4, 5, 6, 7 on this side. 8, 9, 10, 11, 12, 13, 14. I have connected pin number 14 to VCC and 7 to ground. Now the switch is off, the LED is on. When I switch on, the LED is off. Now we are going to find out if 7408 AND gate IC is functioning well. Pin numbers 1 and 2 are the inputs, 3 is the output. We are also going to connect VCC and ground, VCC to pin number 14, ground to pin number 7. I am going to remove this IC carefully like that, and I am going to insert IC 7408 in the same place. The AND gate would produce a 1 only if both the inputs A and B are high or 1, logic 1, and it is going to produce a 0 otherwise. Even if one of the inputs A or B goes low, the output is going to be low. When the output is low, it is going to become high here and the LED is not going to glow. When the output is a 0, it's happening. When the output is a 1, it is going to be inverted here, it becomes a 0, forward biases the LED and the LED is going to glow. If this output is a 0, the LED is not going to glow. If this output is a 1, the LED is going to glow. When the switch is open, the 5 volts power supply through 1 kilo ohm resistance, it is going to give a high to this input, and if this switch is also open, there is a current flowing here to this input 2 and here also active high, and 1 and 1 to these inputs would produce a 1, and that one is going to be inverted to a 0, properly biases the LED, and the LED is going to glow. When the switch is closed, the current flows through this side and the input is going to be 0. When this switch is also closed, the current is going to flow here and there is no input signal. There is just a 0 here, logic 0, and the output is going to be a 0 and the LED is not going to glow. The 0 would get inverted by 7404, and you are going to have a 1 here which doesn't forward bias the diode, and there is no glow on the LED. I have hooked up the circuit. 7408 is here, which is your AND gate. 7404 is here, which is NOT gate. Both the ICs are getting their VCC and the ground lines connected, 14 VCC and 7 ground. And I'm connecting two different color wires for the inputs. From switch 2 and 3, I am connecting to 1 and 2 of the AND gate. Pin number 3 is your output from the AND gate, that is going to pin number 1 of 7404, and pin number 2 is getting the negative of the LED. The other end of the LED goes to 330 ohms and it is connected to power supply. Now both the switches are in the off state. The LED is not glowing. Even if I switch on one, the LED doesn't glow. If I switch on both of them, the LED glows. Now we are going to check if 7432 is functioning well. 7432 is an OR gate. I have marked the pin numbers. This is important when you are starting the experiment. Mark the pin numbers for the inputs and outputs. 1, 2 for the input and 3 is the output for each OR gate, and 1 is the input for the 7404 NOT gate, 2 is the output. OR gate is going to produce a high if any of the inputs A and B are high. Next is to check if 7400 NAND gate is functioning well. Again, the pin numbers are marked. We are going to just take out the IC that is mounted on the breadboard and change it to this, and you're going to check. Next is 7402, which is a NOR gate. In NOR gate, the input pins and output pins have a difference. 2 and 3 are the inputs, 1 is the output for the NOR gate. You're also going to verify the function of 7486, which is an XOR gate. 7400 is going to function like NOT of AND. It is going to do the opposite of an AND gate. Whenever AND gate produces a 1, if you replace it with a NAND gate, it is going to produce a 0. NOR gate, similarly, it is called as NOT of OR. It is going to do the opposite thing of an OR gate. Sorry. XOR gate is a special gate if any of the inputs is low, or when there is a difference between the inputs, the output is going to be high. Observe this. We are going to connect two 7486 logic gates and we are going to check what would be the output. For 7486, 1 and 2 are the inputs, 3 is the output. That 3 has to be connected to the input of the next XOR gate, which is pin number 4 and 5. So 3 has to be connected to pin number 4 and 5 is getting from this line and 6 is the output. In here 7408, two of them we are going to use. 1 and 2 are the inputs for the first AND gate. 3 is the output of the first AND gate. That has to be connected to pin number 4 of the same IC 7408, and pin number 5 is connected to C input, and the output is pin number 6. In the result sheet, you are going to give the general truth table of AND or NAND NOR gates in here, and you're going to write about or record your readings with respect to the circuit that you have hooked up. For the last two circuits, 3 input XOR and 3 input AND gate, you're going to give these inputs through the switches and you're going to get the outputs The outputs high or low you're going to note here, and if the LED is on and off you're going to note them here in this column. LED on corresponds to a logic 1, LED off is a logic 0. Every IC that you use in today's lab are quad 2 input logic ICs, meaning there are 4 logic gates within the same IC. You have to connect 14 to VCC and 7 to ground for every IC. For 7486, if you are considering, you have to connect pin number 7 to ground, 14 to VCC for 7486 for both the logic gates only one time. But for 7404, you have to again connect pin number 14 to VCC and 7 to ground.